All right. Well, hello, Honors Algebra 2. Welcome to Unit 11. This is really the last unit that is something that we're required to talk about this year. While it's maybe not as important for next year as Units 9 and 10 were, it's definitely still an important unit just from a general knowledge standpoint, as well as something that shows up frequently on the SAT and ACT. Plus, it gives me a chance to kind of advertise for some of my other classes. As you may know, besides Honors Algebra 2, I also teach both regular and AP stats. And so, if you like what we talk about in this unit, you might consider taking those either next year or maybe in the year after that. They're just kind of some fun classes that we get to talk about some things that you don't really get to see anywhere else. So, that being said, just so you're aware, Unit 11 is quite a bit longer. I'm going to kind of scroll through these. We're not going to talk about all of them today, but just want to show you that there are a total of 11 sections in this unit. Because of that, we're breaking it up over the course of 3 weeks. So it'll be about four. I believe there's one week where we only have three sections that we'll go through, and then we'll be kind of right on track for a quiz each week over about 3 or 4 sections, depending on the week. That being said, let's go ahead and jump right in here. So 11.1, Intro to Statistics. We're going to start, obviously, with some definitions, and I've already got those written in here for you. So this would be a good chance if you wanted to pause the video and write them down. I'm going to kind of talk you through these definitions, give you some examples of those while you're maybe copying those down. So the first definition, statistics. It's the use of data taken from a sample to make inferences about a population. Um, if we could get data from a population, that would be great. When you can get data from an entire population, that's what's called a census. You may be somewhat familiar with that just because this year is kind of a special year. This is the year that they are actually taking the United States countrywide census. So the 2020 census, I'm sure you've seen lots of advertisements for that. The problem is it's not all that easy to do. In fact, if you think about it, the powerful United States government only has enough manpower and resources to do a census once every 10 years. So, in the meantime, we like to use statistics to still make decisions about the population, but by using a smaller sample. So, we'll talk in just a moment about what a sample is. The next thing, data. It's a numerical description of a sample characteristics. When you think about data, that is where you're thinking about what are we getting our information from, what are the numbers that describe this population. Which leads us into the next definition. The population is a collection of all data, such as a response, measurements, or counts that you want information about. So while it's easy to think about populations as being like the population of a city or a state or the United States, keep in mind populations can also be the number of students at Shawnee Mission North. It could also be the number of fish in this pond, the number of trees in your front yard. Those could all still be examples of a population. Similar to a population is a sample. The only difference is a sample is just a smaller piece of the population. So if we were thinking about the population of Shawnee Mission North, a sample of that population might be just the freshmen, how freshmen are still members of our population, but you can't say that the entire population of Shawnee Mission North is freshmen. Obviously, there's sophomores and juniors and seniors and so on as well. So when we talk about a number that comes from one or the other, we have a distinction that we make. We call a parameter any numerical description of a population characteristic. So if you do have information about the entire population and you have some data based on that, then that is what's called a parameter. Whereas a statistic is a numerical description of a sample characteristic, which actually makes it really easy to remember. Population and parameter, they both start with P. Sample and statistic, they both start with S. So in other words, parameter is just a numerical description or a value from your population. Statistic is a value from your sample. Continuing here, just to kind of again show you the statistical process. In fact, this over here on the left side is what's known as the statistical process. It gives you a really good idea of kind of what we're going to be talking about within this unit. So again, you've got kind of this larger population. Smaller within that population is the sample. From that sample, we're able to collect data and statistics. Using those data and statistics, we then make inferences and we draw conclusions about our population. And then we continue to do that kind of in this cycle. Another good thing that I've got over here for you is just a comparison between parameters and statistics. I'll let you read through that on your own. We've already kind of talked about that, so it'll be up to you if you just want a little bit of extra information. I've got that in there for you. So to show you an example, and very similar to some stuff you're going to see on the homework on big ideas, if you choose to work through that, we've got a drug manufacturer that's interested in the proportion of persons who have hypertension whose condition can be controlled by a new drug that the company has developed. A study involving 5,000 individuals with hypertension is conducted, and it is found that 80% of the individuals are able to control their hypertension with this drug. Assuming that the 5,000 individuals are representative of the group who have hypertension, we are going to answer the following questions. Okay. So, just to read through these questions, then we'll go back and answer them. The first question was the population, so you might start thinking about kind of who we are we interested in, what is the larger group, what was the sample that was taken from that population. Identify the parameter of interest, so we're going to identify what exactly did we want to know about these individuals. Identify the statistic and gives its value. And do we know the value of the parameter? Okay, so let's go through each of these questions. First off, what is the population? Well, it might be tempting to want to say it's the 5,000 individuals. It's actually going to be all individuals with hypertension. So all of our individuals, that could be, it didn't really say that it had to necessarily be the United States or where it might be. So we're just going to assume it could be all individuals with hypertension worldwide. Whereas the sample is those 5,000 individuals that have hypertension. So the 5,000 is actually our sample. The population would then be much larger than that. And I'm not sure how many people have hypertension. If you wanted to Google it, it's going to be more than this 5,000 they took for the sample. So identify the parameter of interest. So our parameter of interest is going to be the proportion of individuals who benefit from the drug. So benefit from the drug. Whereas the statistic is going to be those in the sample. So those in, let me rewrite that here, but those in the sample that benefit. Now we actually know how many that is. If you look in the context of the prompt, we're looking for the number who benefited from our drug, and it actually is telling us how much that was. That's right here, that's the 80%. And so we're going to say that p hat is equal to 0.80. Where this, what I just read out here, was called p hat, that basically just means the proportion from the sample. And we'll talk more about notation in a later section. So then, do we know the value of the parameter? Do we actually know the proportions of the individuals in the entire population who would benefit from the drug? And the answer there is no. In fact, pretty much always you're not going to know the value of the parameter. So what we'll do then is we use the statistic to kind of make it our guess or our inference to say that if 80% of the sample benefited from this new drug, then probably the same would be true of our population, so long as we make sure of a couple things that we'll continue to talk about as we move through this unit. Okay, so obviously we saw one example. This was an example of an experiment that we just saw, but that's not the only way that you can collect data. There's actually a few different ways. So again, I've got some of those here. If you need to pause the video to copy these definitions down, that's fine. I'm going to kind of read them to you and give you some explanations as we go, and that way you can get a better idea for what these represent. So the first thing, sample survey. It's an investigation of one or more characteristics of a population. So the census would be a good example of a sample survey. In fact, that would be a, not sample, but a population survey. So sample survey would be just giving it to certain people. So maybe I'm only interested in the opinions on this from the sophomores who actually maybe drove to school, what they thought about the parking situation. I could give a sample survey out just to my sophomores in class. Different from that is an experiment. That was what we actually just got done with on the previous example. So an experiment is a method that imposes a treatment on individuals in order to collect data. So what it means by imposes a treatment, and that's probably the key part of this definition, is this part right here, imposes the treatment, is that we gave each of the individuals this new experimental drug. Now, likely in that scenario, there were some that got the drug and some that didn't, which would be a control group. And again, we'll talk about more of those details as we move on. But there was a treatment that was imposed. It's not as if those people were just taking this drug on their own naturally. They were given the drug by a company. That was a treatment that was imposed. It's very different from our next definition, which is what's called an observational study. So, in an observational study, individuals are observed and variables are measured without controlling the individuals or environment. The way I always explain this is if you were interested in which trees in your front yard do squirrels like to climb up, you can't exactly do a survey because you can't exactly ask the squirrel what tree it prefers. You can't exactly do an experiment either. You can't exactly, take the squirrels and put them in front of two trees and see which one it climbs up. You have to kind of just sit out on the front lawn in your lawn chair, with some kind of a soda or, sports drink in your hand and just observe and watch to see which trees the squirrels like to climb up. All right, so that's survey, experiment, and observational study. Randomization, one last thing that we'll talk about as we continue to move on, and we'll work through a couple examples here. Randomization is a process of randomly assigning subjects to different treatment groups. So that would be something that gets used oftentimes in an experiment, but can also take place in some other contexts as well. All right, so let's look at a couple examples. Does reducing screen brightness increase the battery life in laptop computers? To find out, researchers obtained 30 laptops of the same brand. They chose 15 of the computers at random and adjusted their screens to the brightest setting. The other 15 laptop screens were left at the default setting of moderate brightness. Researchers then measured how long each machine's battery lasted. Was this an observational study or an experiment? So what we really want to think about, did we impose some kind of a treatment or did they just observe all of these laptops? In other words, did they change anything? And I would say where it says that they chose 15 computers and then adjusted their screens to the brightest setting, that to me says that they imposed a treatment. That tells me that this is an experiment. All right, number 2, does eating dinner with their families improve students' academic performance? According to an ABC News article, teenagers who eat with their families at least 5 times a week are more likely to get better grades in school. This finding was based on a sample survey that was conducted by researchers at Columbia University. So again, here's that idea of a sample survey. But let's see which kind it was. Was this an observational study or an experiment? So let's think about, did they impose a treatment? So they were looking at teenagers who ate with their families. And it doesn't, to me anywhere, say that they made some students eat with their families and some students not eat with their families. So if there was no treatment imposed, then that would be a clue that this is an observational study. And for justifying, you can just say that there was no treatment imposed. Again, that's saying that it wasn't like they told some students to eat with their families and others not to. They just observed whether or not they were eating with their families and then how well they did on their academics. Okay. A couple more definitions for us here. We're going to start to talk about some of the special types of samples that we can get into. The first of which is what's called a simple random sample, which is oftentimes abbreviated to be what's in parentheses there, which is an SRS. So it is a sample in which each member of a population has an equal chance of being selected. So 2 steps to finding an SRS. Step 1 is that you label all of the individuals that you're interested in. Step 2 is that you're then going to select individuals using some chance process. And by chance process, we've got a few different things that can be. For the most part, I'm just going to share with you the graphing calculator. There are some other methods as well that we'll kind of discuss, but graphing calculator will be our primary way of randomizing and selecting. So in this example, the management company of a local mall plans to survey a random sample of 3 stores to determine the hours they would like to stay open during the holiday season. Use the random digit generator on your calculator to select an SRS of size 3 stores. All right, so to do that, remember 2 steps to finding an SRS. Step 1 is that we're going to label all these. So we're just going to go through and put a numerical label on it. That's probably easiest by just counting up from 1. So 1, 2, 3, 4, 5, 6, 7. I believe there's 3 columns, so it should go all the way up to 21. So 10, 11, and then 12, 13, 14. And then Old Navy will be 15, 16, 17, 18, 19, 20, and Zales Diamond Store is 21. Okay, so step number 2, we're then going to select individuals using some chance process. So I'm going to show you how to do this on your graphing calculator. If you don't have a graphing calculator at home, there are some random number generators that you can just use online, and just feel free to use those if you don't have a graphing calculator. They'll work just as well. But if you do have a graphing calculator, the way that we're going to come up with some random numbers is we're first going to go to the math button. Once we've hit math, we're going to go over to probability, which will be the third menu in that math menu. And then we're going to make a choice. There's a few different random numbers you can generate. Rand_int will just give you a random integer, and it'll tell you kind of what numbers to be between, and so on. Random_norm will give you a random normal number. Random_bin will give you a random binary number. And then random integer no repeating will make sure that you don't repeat numbers. If you have that option, let's go ahead and use it. If not, just use option 5 and it'll work just as well. Okay, so then it's going to either take you to a menu or it's going to take you to the home screen. If it gives you a menu, then what you're going to choose, your lower is going to be whatever the lowest number you chose to use for a label. So for me, that lowest number would be 1, and then press enter. For upper, we'll pick the largest number, which in this case was 21 for Zales Diamond Store. And then for in, you're going to say what the size of your sample you want is. And if you notice, we want a SRS of size 3, so that tells us that we're going to want 3 numbers. Now, once you hit paste, it should take you to this screen. This is where if you didn't have a menu pop up, this is how you should be typing it into your calculator. It should be 1, 21, 3, and then close your parentheses. And then once you're done with that, you can press enter, and it's going to generate 3 numbers randomly. If you did get an error, you might just go back, and if you try to use rand_int, no repeating, the first time you might just go back into that math menu over to probability, and instead of hitting the no repeating option, you might just hit rand_int for option 5. That'll work just as well. Now, if it does repeat, you're just going to have to run it a couple of times until you get 3 of them where there aren't any repeating numbers, because obviously you wouldn't want to pick a store twice. But I'm just going to go ahead and go with the numbers that I came up with, which were 15, 17, and 14. So that would be that we are going to have Old Navy, as well as Panda Express, as well as the Nike factory store, be our 3 stores that we ask regarding the new hours for their holiday season. Okay, cool. So for the next one, so that was simple, or our simple random sample. We're now going to talk about what's called a stratified random sample. So a stratified random sample is slightly different. It's a sample in which a population is divided into smaller groups that share a similar characteristic, and a sample is then randomly selected from each group. So how is it different? Individuals don't necessarily have an equal chance of being chosen. That's the big difference. So individuals do not necessarily have an equal chance to be chosen. The other thing that makes it different is the idea of separation into groups. So separation into groups. When it was a simple random sample, we didn't have any separation. It was just looking at the entire population as a single group. Now we've got it simplified into these different groups. So when is it beneficial to use a stratified random sample? I think that the best answer to that question is when groups occur naturally. So if you already have kind of naturally occurring groups, that's when a stratified random sample is going to be best. To give you an example of this, let's think about Shawnee Mission North. There's kind of a nice separation into groups that occurs naturally. The one that I kind of think of is the separation based on grade level. So you've got freshmen, sophomores, juniors, seniors. If you wanted to do a stratified random sample, you would separate them into their grade levels and then randomly pick a couple from each grade level, which is kind of nice because the benefit is you're guaranteed to get some from each group. So that's kind of the benefit, is that you're guaranteed some variety. Um, you're not necessarily guaranteed variety if you don't do that. So if I was just going to take a random sample from the school, if I were to just randomly select 5 people, it might happen to be that the 5 people I pick are 5 freshmen. And if we're interested in how well the parking lot is set up, then picking 5 freshmen might not be the best, because not all that many freshmen drive to school. It might be better to use a stratified random sample where we get freshmen, but we also get sophomores and juniors and seniors. And that way we're guaranteed to get some people that actually have an opinion about the parking lot at school. So how do you choose a variable to stratify by? That's kind of up to the person that's doing the experiment. Again, it's probably best to do it based on the ones that are naturally occurring. So like the grade level and so on kind of work best. But it's kind of up to the person doing the study. It really depends on whether or not you think it's going to have some kind of an impact on your results. So how can we stratify using the mall example? You might already kind of have some thoughts or ideas on how that would work. If you do, let's think about what would the strata be. To me, I would make my strata be the different types of stores. Because if you notice, we had some food stores, we had some clothing stores, we had some kind of miscellaneous stores. But it would be kind of nice to make sure that we got some food stores, some clothing stores, and some miscellaneous stores. So then you, in order to select your sample, you would divide into the strata. And in this case, let's just go with the ones that I picked over here. So the food, clothing, and miscellaneous, and then pick one from each category. And that way you're guaranteed to have one of the food stores, one of the clothing stores, one of the kind of miscellaneous shops. Each one will have a representative there. I got kind of lucky when I did this that I actually did already have one food store and one kind of clothing store. But if you notice, I don't have any of the jewelry stores, and I don't have the bookstore, some of those miscellaneous type shops. It would have been nice to have had one of those in there instead of having 2 clothing stores for Old Navy and Nike. So that's kind of the benefit of a stratified random sample. Let's talk about another cluster, or another sample. Let's talk about a cluster sample. So a cluster sample is a sample in which a population is divided into groups, which are called clusters. And then all of the members in that cluster are then randomly selected. So why do we use a cluster sample? Typically we do that if there is separation based on a location. That's typically where you'll see cluster most oftentimes used. So how is it different than a stratified random sample? We're going to select all individuals from whatever cluster we pick. So that is a little bit different from what we did when we talked about stratified random sampling. In stratified random sampling, we were going to pick one from each category. In a cluster sample, you would then pick all of the individuals from whatever category you picked. So if you say you pick the clothing cluster, or clothing strata, I should say, then you would sample all of these stores that were clothing stores. So how would you use cluster sampling within the mall example? What would the clusters be, and how would you select the sample? To me, if I'm thinking about location in the mall, depending on the mall that you're at, most malls kind of have a couple of different floors, a couple of different stories to them. So for me, I would make the clusters the different floor levels. So, first floor, the second floor. Some malls have a third floor, and so on. And then how would you select the sample? Then you would just pick a cluster at random and then use all of the stores that are in that cluster. So let's say you picked the first floor as your cluster, then you would actually use all of the stores from that first cluster rather than just a few from that cluster. Or let's say you pick the third floor, then you would kind of sample all of those. So that one wouldn't necessarily work out as well with the mall example, because I bet you there'd probably be more than 3 stores on each floor. So you might even have to make your cluster even more specific. Like the north end of the first floor, the south end of the first floor, the east end, and then maybe pick a cluster based on that. So we might have to separate even a little bit more than doing it based on what level the stores were on. So last thing to talk about today, there are some other types of samples besides the ones that we spend a little bit more time on. These are a little bit more straightforward, so we're not going to spend as much time with these. There's what's called a self-selected or voluntary response sample. That's a sample in which the members of the population can volunteer to be in the sample. So oftentimes that's kind of like the surveys that get sent out from PEP Club or journalism or whoever it might be, and they just use whatever information they get from the people that decide to answer. That would be an example of a self-selected or voluntary response sample. A systematic sample is a sample in which a rule is used to select members of the population. So with systematic, maybe you're interested in how much sleep students got for the previous night. So maybe the survey was going to be asking every 10th person to come in the doors at Shawnee Mission North how much sleep they got. So in other words, every 10th person you'd ask how much sleep they got. That would be a systematic sample. A convenience sample then is just a sample in which only members of the population that are easy to reach are selected. So the example I would give if we were in class is that the class would be a very easy, convenient sample for me to take. I would just ask everyone that was in the class at that time. I can even do it by a show of hands. It's very easy to reach those that are selected. But not always the most accurate and the best results that you can get, especially with the types of studies and samples that we have here at the bottom. That being said, guys, there is going to be an activity later this week. I'm going to get that posted for you. That activity is going to have you collecting data in your neighborhood. It's going to have you collecting data on the number of cars that are in each driveway, or if you live in an apartment complex or something like that, the number of cars within each maybe shelter or each parking spot, or we'll kind of talk more about it then. But make sure that you know what the difference is between these types of samples before you do that activity. So if you need to come back and rewatch this video before you do that, I would just encourage you to make sure that you have a good understanding of the different types of samples before you try to work through that activity. If you don't understand them well enough, then that activity is going to be very difficult to get to work through. So it'll just be a fun activity, maybe get you out of the house, out of the apartment, out of your room, out and moving around and putting some of what we're talking about in class into practice. That being said, we're going to talk the next time about data displays. So we're going to talk about kind of what are we going to do with all this data that we're collecting? What is it going to look like? How can we arrange it into a way that's easy to view and easy to use? So that being said, guys, have a good rest of your day, and I'll talk to you next time.